All right, everyone, this is the video that you're going to use for the second page of homework 6-17. The second page should be down here. It says watch my video and then complete these notes. So this is going to be introducing chapter 7. Chapter 7 is going to be the start of the foundation of the last theme of statistics that we do, which is called inference. It's very important. And actually, this is really where everything we've done this year culminates into one single theme of statistics. So we collected our data, we analyzed our data, we describe how to collect our data well in an unbiased fashion, and now we're going to start to analyze it and make inferences about it. But in order to do so, we need some key vocabulary that we're going to be using throughout this next couple of months. So the key words here are parameters and statistics. So statistic starts with the letter S. And a statistic, you probably have heard the word statistic like nonstop, and you're like, oh, these are statistics. These are statistics. They're numbers, right? But what you may not have realized is that a statistic only describes a sample. So it comes from a sample. Whereas a parameter starts with P, comes from a population. Okay, so statistic starts with S, sample starts with S. A statistic is a number that describes a sample, and a parameter starts with P, population starts with P, parameter comes from a population. Okay, so if I use the word this is a statistic, from now on you're going to say, oh, that came from a sample, which is a small group that's supposed to represent the parameter. So basically, the whole concept of AP Stat is we start to talk about how it is unrealistic for us to know all the information about the population because it's too big, it's too hard to reach. We can't poll everybody and get a census all the time. So what we do instead is we create a sample and we find the sample mean. And we hope that that sample is a good enough sample that it will estimate the true population mean. And then we get a sample and we find the proportion. And then we hope that if it's a good sample, it will estimate the true proportion, etc. So the symbols that you're going to see that are most common that we use in the next couple of months are, for the mean, the sample mean, we use the symbol X bar. That means it came from a sample, okay? But as soon as we're talking about a population, instead of using X bar, we're going to use the symbol mu. And earlier this year, you may have seen both X bar and mu, and you probably have been saying, why is she using X bar sometimes, and then other times she's using mu? If it's mu, it's the entire population or every possible iteration of the random variable. So it's basically everybody. But if it's a sample, like a small group, then we use X bar. Same thing with proportions. If it came from a sample and we find the proportion of something, it would be called p hat. But if it's a true proportion from the entire population, we use the symbol p. So let's do an example. A quick one in my head would be, let's say the senior class wants to vote on senior superlatives for someone who is the best smile. And the true proportion of people who voted for the winner of Best Smile is called P. That's the true proportion of everyone in the senior class. Okay, but now let's say they do a vote and they do the vote on Castle Learning or Microsoft Forms. And because they do it on there, maybe not everyone votes. So because not everyone votes, that's a sample. And the proportion of people who voted for that person for Best Smile is actually called p hat because it came from the sample. It's a sample proportion, okay? So we hope that the p hat is a true good estimate of p, which is the true proportion of everyone in the senior class. Okay, now ideally, when we do samples, we want it to be a simple random sample, which is a sample randomly selected from the population of interest and not one that's just like a voluntary response like the example I just mentioned. The last symbols that you guys are going to see this year have to do with standard deviation, which is a measure of spread. So if it is from the sample, we use the letter S, and if it's from the population, we use the letter little sigma, which you guys have seen before. So remember S and P. Sample starts with S, statistic starts with S, so a sample is a number from, a statistic is a number from the sample. Parameter starts with P, population starts with P, so a parameter is a number about the population. Now let's do an example. Number one, the Gallup poll asked 515 randomly selected U.S. adults if they believe in ghosts. Of those respondents, 160 said yes. So first I want you to ask yourself, is this a sample or a population? I'm hoping that you answered that it is a sample. So this is N, the sample size of 515. And it's not everyone, right? So we're using this sample poll specifically to estimate the true population of US adults. Okay? Now, out of the 515, out of the respondents, 160 of them said yes. This is going to be a fraction out of the total, and so that's going to be called a proportion. And specifically because it comes from the sample, it's going to be a statistic. And we're going to do 160 divided by 515. Okay, that's going to be called the sample proportion because it came from the sample. So if we do 160 divided by 515, we're going to get 0.31-ish, okay? 0.311. So if we use our sample, we would say about 31% of our sample said that they believe in ghosts. So can we use that sample to estimate the true proportion of everyone in the country who believes in ghosts? Well, if it's a good sample, we can. So the unknown parameter that we are interested in is called P, and that is going to be the true proportion of US adults who believe in ghosts. Okay? So the number that we got, 515 out of, 160 out of 515 is called a statistic because it describes the sample. And our hopes are that we use it to estimate the true parameter, which is called P. And it is unknown because are we really going to poll everyone in the country and ask them if they believe in ghosts, right? All right, let's go on to number two. Number two, our carload of ball bearings has a mean diameter, let's underline that, of 2.5003. Notice we're using the word mean here now. This is within the specifications for acceptance of a lot by the purchaser. By chance, an inspector chooses 100 bearings, by chance, so randomly, from the lot, and they have a mean of 2.5009 centimeters. Because this is outside the specified limits, the lot is mistakenly rejected. Okay, so we have two numbers here that, well, three numbers that I circled. The first one is, actually, I'm gonna put it last. I'm gonna go to the last one here. So we took a sample of 100 from the lot, and out of that sample, they had a sample mean of 2.5009. That sample mean is called X bar. And if it is from the sample, we call it a statistic. Now, that is the sample of the 100 that were randomly selected. We hope that the X bar estimates the true mean, which is called mu, the true mean of all the carload lot of ball bearings. And it turns out they actually gave us that true mean, mu. They said it was 2.5003. This number is called a parameter because it describes the population. So the sample is the 100 selected ball bearings from the lot. And the population is all the ball bearings in the lot. And the mean of those is the mu, which is the true mean of every single one. And then the other one is x bar. That's the sample mean because it's just from the sample of 100. So basically, that is it. You need to know the difference between sample and population. You need to know the difference between statistic and parameter. And you need to know the difference between those symbols that I mentioned today. And notice the AP exam tip says that many students lose credit on the exam because sometimes they're talking about a sample instead of a population or a population instead of a sample, and they're not necessarily sure which one it is. When defining a parameter, we suggest that you include the word all or true in your description so you know for sure that you are not referring to a sample statistic. So that's what I tend to do all the time. So if you go back to number 1 with the ghosts, I did say the population is all US adults because that's everyone. And then the unknown parameter P is the true proportion of all the US adults. So that's what makes it a parameter and not something from a small group. All right, that's it. That's it.